Yeah, thanks for the invitation. I mean, why quantum computing I get asked the question about why quantum computing into Web3, FinTech presentation and short trade. I think what is important to understand is that quantum computing is a foundational technology which underline many other technologies that we are using and we are going to use. So why I'm telling you that is that we are currently in the second quantum revolution. The first quantum revolution that started in 1925 with Heisenberg and Schrödinger was all about to try to understand how the microscopic world was working and how to predict behavior. That led in the 60s, a little bit later, to the lasers, to the MRI, to the electronic. So everything we have, and the fact that I can talk to you, that I flew to here, is thanks to the first quantum revolution, which is underlying 2/3 of the current GDP. So, since the 90s, we entered the second quantum revolution. Because the first was using the microscopic effect of quantum technology. Lasers, it's billions of photons. Electronics is billions of electrons, and so on. Here, what we are talking about is how can we use the individual microscopic electrons, photons, to do things differently. That's the second quantum revolution. And what is important to understand is that this is going to lead to many new discoveries, to a real disruption into how we do things, especially in terms of IT. IT is great. The CES is great. But the problem of CES and IT and stuff like this, it consumes a lot of energy. And the environmental impact of the IT sector is growing faster than any reduction we are trying to do. Take also the aerospace industry. One of the key problems, sorry for the long introduction, but it's important to understand the content and why we are putting so much money onto quantum computing. Aerospace industry has to be decarbonized by 2050. The key problem is that right now all progress that are made to reduce consumption of fuels and so on is completely erased by the increase of the traffic. At some point you need to be able to find a technology that will reduce drastically consumption, because the human behavior is to consume more and more. So what we are trying to do at Colibri, the key problem of quantum computing today, it's deep tech. So there's many players, there's many hardware providers, algorithms, etc. You know IBM, you know Google, you know IonQ, and so on. It's a nascent technology, so there's many players. And the problem is that if we want people, end user, aerospace, automotive, chemistry, whatever, to take on quantum computing, we have to simplify. We have to make using quantum as easy as possible and integrating into existing business workflow. And moreover, you don't have to understand quantum to use quantum. Like you don't need to understand how your phone works in order to use your phone. That's the same things. So we are positioned at the application and algorithm layer. We let the hardware player build the hardware, the quantum computer, and we deal with the software and the business solution as well. So it's really to try to put things together to accelerate quantum adoption, because it's key. We do think it's going to be as big as the first quantum revolution. So what do we propose? We propose it's a kind of quantum production chain. You have a business problem that you cannot currently solve using existing technologies. Let's take aerospace and new materials. Building new materials, creating new materials, it's really difficult. So you would say now you have generative AI. Generative AI is based on what exists and trying to find what could exist from what exists. Which means if something does not exist, it's going to be difficult for generative AI to create it. Quantum goes to the fundamental of physics. So it's able to try to figure out something that never existed into something that could exist. That's the difference between generative AI and, for example, quantum. you could always use quantum resources to power also generative AI. So you have to understand that generative AI and quantum computing are complementary. So that's a key point to understand here. So in order for that to happen, you need to take the problem, transform into a quantum algorithm, run on different hardwares that are most efficient to run this specific task, and give back the results. That's the production chain. And for the end user, there should be no difference. And just using any solution I have at hands to do something that I was not able to do before. Or I was able to do it, but it was consuming far too resources. So that's the goal, and that's what we are trying to propose here. Our business model is really simple because a lot of people say, what is your market size? How much revenue do you have every year? I mean, we are in deep tech in a market that does not exist yet because we are still looking at the availability of the hardware. That said, we do think quantum computing will be a singularity event. At some point, hardware will exist, and suddenly the market will grow. We've seen that with big data, we see that with the cloud computing. At some point, there was an exponential growth because the market was ready. But if you wait until it's ready, it's already too late. Because in order to have access to this technology, you have to be able to have the talents, the understanding, the use case, and understand which hardware can solve. If you have not done your homework before, there's no way you can benefit from the quantum technology revolution. That's where we help. So the first market we are addressing, we want to open our platform, which is a platform, to the community. So it's an open source model. We want engagement. So we want people to prepare. And we don't want them to pay that much to prepare. We want them to prepare to understand the use case that can be available. We want to work with academics in order to be able to have the right algorithm for the right use case and the right hardware. And then when the market will start to be available to grow, we'll propose a platform as a service. So you pay as you use. Very simple. If you don't consume, you don't pay. If you consume resource, you pay. So that's really simple as a business model. 2 stages. Short term, the platform open to the community to bring people to our platform. Second step, providing to the business as a pay-as-you-use model. So the good news is that there's competition. When I used to work for Amazon, they always say, if there's competition, there's a market. So there's some competition in this sector, but not that many, in fact. If you look at the potential of the market, there's really not that many players in quantum computing. If we look at how we address things, there's few things which differentiate us from the other competitors. First is we are hardware agnostic. We really want to be able to leverage any computing hardware paradigm, be photonic, be electronic, be in spin, be in ion, be in anything, superconductor. We need to be able to choose the right machine, the right hardware for the right use case. We are also using different type of algorithm. Many of our competitors went from a laboratory, they use the algorithm, and then they based everything on the algorithm. We want to be multi-algorithm because we don't think one algorithm will solve everything. That enables us to attack many potential use case. As I said, right now we are focused on aerospace because there's many challenges they have to face, and there's a long-term look at it, and there's a lot of money that is going to be invested in this sector to be carbon neutral. So, but it can be applied to automotive, pharmaceuticals, and other business verticals. A little bit about ourselves. So we have Hassan Boudjil, the business guy. There's myself, PhD in physics. I've been lucky enough to have professors like Serge Haroche and Alain Aspect, 2 Nobel Prize in physics. So, I mean, just as a side note, it's interesting to see that France is in terms of academics and even hardware, is learning a lot in terms of quantum computing. So it's not by chance. I didn't wake up one day and thinking about quantum computing. But that said, my PhD was a long time ago, and then I went to work for more business-oriented companies like Oracle, Google, Amazon. But the good thing is that these companies have a very product-oriented philosophy. We want to put a product to the market. Deep tech is what deep tech. At the end of the day, you have to solve a customer problem, period. You can be the most beautiful academics. It doesn't work until you solve a problem that's really a pain for community. So that's the focus here of us. That said, just to be transparent, right now we are at CES for the networking and to raise funds. We already raised 1 million with a German VC, early bird, and now we are looking for a little bit more money. I mean, we are software-based, platform-based company, so we are hiring talents. All the money we are asking is to hire talents, because we need to crack difficult topics, so we need to be able to hire the best talents from all over the world. I mean, you will see our team in the next slide, it's coming from all over the world. So that's key. And also we need to build partnerships, academics and hardware partnerships. That's what we use the money for. The team. That's really the most important. When there's only one thing you get from this presentation, it's a team. So it's a pretty diverse team. We have people from India, from Egypt, from Germany, from Italy. So there's a pretty diverse and really talented team of PhDs and engineers. We also have professors, academic professors working with us. That's really diverse in terms of thinking. We need people to be able to think out of the box. Then what is also important is the partnerships with hardware, with academics. That's key for us to be able to build that and to be really becoming the center of the quantum ecosystem. That's really the goal. This platform will succeed if we are able to provide an open platform for our partners and a platform easy to use for end users in terms of business. So overall, thanks for listening. So really the point is to make access to quantum computing easy, because we do think we are, is the second quantum revolution, going to transform many use cases. And again, quantum computing is the foundation technology that will power up many other technologies. So that's key to understand. The end user will not see quantum, never. Like you don't see quantum in your phone. But this will power many different technology and disruptive approach that we are going to see in the next following years. Thanks for listening.
Thank you so much. I believe the purpose was very clear. A lot of energy. So the more the days goes through, the better energy you provide. Is it quantum lake? Thank you. Okay, so just a second.